Assalamualaikum warahmatullahi wabarakatuh and a very good day. Welcome to my final year project presentation. Let me introduce myself. I am Shahriman bin Ibrahim from School of Mechanical Engineering. I will be presenting my final year project entitled Design and Analysis Stirling Engine for Rural Area Application under the supervision of Dr. Hasanuddin bin Abdul Kadir. The goals of the project were the design and a simulation of a feasible system configuration of the implementation of a Stirling engine for electrification, pump generator and other uses of rural areas. Using biomass furnace to heat the Stirling engine was one of the project's primary objectives. For economic concerns, the Alpha type Stirling engine was chosen since numerous components from industrial mass manufacturing may be utilized. All kinds of biomass such as agricultural waste, log or chipwood and red palm oil fronds may be used as fuel. Robert Stirling designed the Stirling engine in 1816, which is a closed-cycle piston-type energy converter. The cycle of practical Stirling engines exhibits a considerable number of deviations from the ideal theoretical cycle, and as the result of these deviations, performance value of practical Stirling engine such as thermal efficiency, cyclic work generation, running speed, power output, specific power and torque become uncompetitive with internal combustion engines. According to piston configuration, Stirling engines are also classified in three groups as alpha, beta, and gamma. Isothermal compression, constant volume heating, constant volume expansion, and constant volume cooling are the four operations of the Stirling engine's theoretical cycle. The cycle of practical Stirling engines exhibits a considerable number of deviations from the ideal theoretical cycle. And as the result of these deviations, performance values of practical Stirling engine such as thermal efficiency, cyclic work generation, running speed, power output, specific power and torque become uncompetitive with internal combustion engines. Stirling engines have too much application fields. Due to external heating property, Stirling engine enables the conversion of clean and renewable energies into useful energy, from which expand based on the first of the literature review. Manufacturing and testing of an alpha-type Stirling engine written by Yilmaz and others 2018. Isothermal compression, constant volume heating, constant volume expansion and constant volume cooling are the four operations of the Stirling engine's theoretical cycle. Referred to thermodynamic and dynamic analysis of an alpha-type Stirling engine and numerical treatment summarized by Karabulut 2018. From a journal which is Electricity Production in Rural Villages with a Biomass Stirling Engine, which is been written by Prodesser 1999, mentioned that when it comes to overall engine efficiency, temperature and flow rate are critical aspects to consider. Burning biomass in a burner rather than a Stirling engine is possible due to the use of an external heat source. From the fourth journal written by Hauda Hashim and al. 2020 have mentioned that during heating, the working gases pressure will rise and on cooling it will fall. The gas within the Stirling engine is constantly expanding and contracting as it moves from the heated to the cold sides. The movement of the piston is transformed into mechanical work that may be used. For the fifth literature review, which are summarized by S.T. Su and al. 2020 said that for the distributed power production, Stirling engines may operate at ordinary fuels like gasoline or natural gas. Stirling engines are especially adapted to utilize the heat from a solar dish concentrating system or burning biomass due to their external combustion characteristics. As we can see from Journal of Optimized Piston Machine for an Alpha-type Stirling engine, written by Masir and the others 2020, highlighted that Stirling engines are considered to be good candidates for the use of waste heat, which occurs in many technical applications and which is often dumped into the environment without use. The sixth literature review, which is Power Optimized Sinusoidal Piston Motion and its Performance Gain for an Alpha-type Stirling engine with limited regeneration, brought by Messer and others 2020, said that Stirling engines, which have a proven track record of dependability and efficiency, might be one option for achieving this aim. Optimizing the motion of the piston may improve one's performance. Next, it was observed that the piston stroke and cylinder diameter variables have more significant interactions with the rest of the parameters due to their strong influence over mass flow, which has been highlighted in the Journal of a Numerical Study of Influence of Design Variable Interaction on the Performance of a Stirling Engine System, is last and all published on 2020. Last but not least, the summary assessment of the Stirling engine performance comparing two renewable energy sources, solar and biomass, wrote by Ferreira and published on 2020, mentioned that the Stirling cycle engine can theoretically effectively transform heat into mechanical work at a Carnot efficiency level. The literature also demonstrates the necessity of working fluid selection. Indeed, switching from air to hydrogen as the working fluid of the Stirling engine may enhance its power by a factor of 10. Poor nations' rural regions are often disadvantaged when it comes to having easy access to power, providing this service in distant, sparsely inhabited areas with rough terrain and low usage necessitate expensive rural power projects. Rural regions, on the other hand, are determined by the energy demands of their residents, as well as the requirement of local irrigation and agro-processing or other natural resource-related business. To design a Stirling engine of a feasible system configuration for the implementation of electrification, pump, generator and other uses of rural areas which is heated by the biomass furnace, and conducting simulation on the mechanism and component that been applied at the Stirling engine using the computer-aided design software. The important part for this project is to ensure the Stirling engine can be implemented for electrification, pump generator and other uses for rural applications. Due to the fact that the data being used is old and hence less dependable, the final result will be less accurate. The methodology plays a critical role in the smooth and effective completion of the project. There are 7 primary procedures to be accomplished in this study, which are basic concept, selection of engine type, basic structure, component design, thermal analysis, detailed design and 3D modeling. The basic concept was done to determine on some parameters for the Stirling engine such as the application used, the target power that can be produced, the output efficiency and the size of the Stirling engine. The mechanical configurations of Stirling engines are generally divided into 3 groups known as the alpha, beta and gamma arrangement. For this project, alpha type Stirling engine is the chosen one since the requirement for this project are suited with the specification highlighted and considering on use at rural area. Basic structure can be determined by understanding on the type of the Stirling engine, selecting the location of cylinder, structure of heat exchangers and crank mechanism were adapted after consideration about the Stirling engine type due to different on the parameters mentioned. Some of parameters need to be identified during this stage, focusing on the component had been used for the Stirling engine such as the heat exchangers, crank mechanism and seal device. The component design playing an important role on achieving a perfect Stirling engine based on the requirement mentioned. For the 4th stage, which is thermal analysis, analysis of engine performance is carried out in terms of shuttle pumping, cylinder wall, heat conduction and heat exchangers uses as well as pressure and temperature losses. Stage 6. Detailed design. On this stage, the size of the piston, the length of the crankshaft and the volume of the cylinder bore will be determined in order to achieve the requirement power and efficiency of the Stirling engine. Last stage, which is 3D modeling, simulate and analyze. By using computer-aided design such as CATIA and SolidWorks, the Stirling engine will be 3D modeling according to the information that had been gathered. All the dimension and location for each component is a key source of concern in this stage. Preliminary result, a few 3D models of Stirling engine have been built using computer-aided design CAD tool, which is SolidWorks. The 3D model is the simple design based on the Stirling engine mechanism used nowadays. The figure shows the full 3D model of the basic Stirling engine. Simulation also have been gone through for the basic Stirling engine 3D model, which consists of some movement of the mechanical parts like the piston and crank rod. End of this project, a 3D model of alpha type Stirling engine that heated by biomass furnace will be built. All the information that been gathered from each stage will have significant influence on the result of the 3D model simulation. Gantt chart shows my project flow through final year project 1 for this semester. The project planning is shown by dark blue color while the actual is shown by the sea blue color, whereas the time taken represented by horizontal line. And this is my references for final year project 1 proposal. Now at the end of my presentation, if there is something which need to be clarifying, do contact me at my email or reach out by calling the phone number. Thank you for your attention.